Okay, so go back to it. One of the ways to do this is to plug in the -3 for x and the +3 for y in both of these inequalities and see if you have a true statement. The other way is to graph the two inequalities and see if that point is in the shaded area for both. Okay, so what I'm going to start out by doing is just going ahead and graphing these two. So I'm going to graph this one in green, and I'll grab this the second one in purple. Okay. If I do, they're in that box down there. I don't know. Okay. Alright, so let's start with the second one because it's already set up ready to graph. It's in your slope-intercept form. And so we're going to start out by plotting the point -2 on the y-axis. So on the y-axis I go down 2 and put a dot. Okay. So my b was -2. Okay. In this problem, m is also -2. So I rewrite that as a fraction of -2/1. That means I go down 2 and to the right 1 from that purple dot already.
Thank you.
Do what? The blue dot is the point -3, 3. It's the one they ask us about as a solution. Alright, so my line itself looks something like that. And my shading needs to go which direction? Yeah, it says y is less than, so it needs to go down. Yeah. So if I'm shading, it's going to go to this direction. Okay, so before I even move to the second inequality, what I'm going to ask is the blue dot, is it in that shaded region? Yes, so it could be a solution. It's a solution for that one inequality, but we need to check to make sure it's a solution for both. Okay? Anytime you see a less than symbol, okay, listen, anytime you see a less than symbol, you're shading down. So if I'm looking at hold on a second. Okay, if I have a less than symbol, if the line is slanted this direction, left than shading is always this way. If the line is slanted this direction, less than will be this direction. So if it's a less than symbol, this is the way you would shade. If it was greater than, you'd shade the other way. So greater than would go this way if the line slanted that direction, or this way if it's slanted that way. Maybe that'll help.
You need to start getting those color pencils. So
You are perfectly okay bringing colored pencils.
no,
I don't have that. I don't have that many to give everybody colored pencils.
No, I'm saying though, you can't go to the library tomorrow. That's what we did in first facility. I can go get them for you, you know what I'm saying, tomorrow.
I'll look. But one of the problems with that is you're not going to be able to have them on test and stuff. These two down here. She was asking me how to know which way to shade. And so I was trying to show her that if it's a less than, you shade where the black is. It depends on which direction the line's slanted. If it's a greater than, then you'd shade where the red is, depending on which way the line's slanted. Okay, so let's look at that one up here. The first one. The first thing I need to do on this first inequality is add the 2x to both sides. So it ends up being y is less than or equal to 2x plus 1. Because that minus 2x would need to be switched over. So I'll go ahead and write up here, b is going to equal 1 and m is equal to 2. Okay, so if I graph now the one that's in the slope-intercept form, my b is a 1, and my slope is up 2 over 1. This time it'll be a solid line instead of a dashed line. So it should look something like this. Okay, and then which section should I shade? It is a less than symbol. It's a less than symbol, so it's slanted this way, so I'm going to shade down to the right.
Well,
Okay. Is that blue dot in the green shaded area? No. So the question asks, tell whether negative 3 is a solution to the system. Okay, yeah. Yeah. It's getting really, really annoying because if I'm having to talk loud for me to be able to understand myself, this is a problem. So, hey, I don't want you talking at all. I didn't say I want you whispering. I don't want you talking. I don't want you turning around looking at people, slinging stuff around. I don't want you making noises. I don't want anything. I want you paying attention this way. Hey, don't sling it loud, stronger now that I say something to you.
whoa.
Yeah, it becomes a pretty big issue when we're trying to have any kind of discussion. when somebody actually does want to pay attention. Someone had the question of which direction do you shade, and so the black one is the less than symbol, and so it depends on which way the line is slanted. You shade where the black is shaded. Okay. What other questions do you have about this first problem? Yes, ma'am. Okay. So let's look at the next one. All right. Yeah, if you haven't done number 4 already, okay, go ahead and let's look at number 4. I'm going to work it up here, but I'll give you just a second to get it written down and started on. We'll look at one example of graphing. This time I'm not worried about what points are solutions, because it doesn't ask me about the point -3, 3 or anything, but we do want to make sure that we're graphing it correctly. Still looking for the spot that's graphed in both equations, or shaded in both equations.
Is that a minus or?
It's a negative x.
That makes me wonder.
Yeah. So you're on the top. What's my y-intercept on the top? Okay, what's my slope? And 2/1. Okay, what's my y-intercept on the bottom? Okay, my y-intercept's 1, and what's my slope? -1/1. Okay, so when you're graphing them, always start out with your slope and your y-intercept. That's just the easiest place to start. Just kind of reminders. Okay, so we're starting that first one. If my y-intercept's at 2, I'm going to go put a dot on the 2, and then my slope says I got to go up 2/1. Okay, so then I just keep going the other direction. I go down to the left one. Okay, is this going to be a solid line or a dashed line? Okay, it's going to be a solid line simply because it's a less than or equal to. Remember that the equal to part is what determines whether it's solid or dashed. Okay, now which way is it going to be shaded? What symbol is that real quick? Less than. So if we go back up here, the less thans were in red. No, less thans were in black. It's slanted this way. So it's going to be shaded to the right now. Okay, so that's that one set up. Okay, the second inequality. The y-intercept's at a positive 1, and my slope is a down 1, so down 1 to the right 1. And you can do, instead of going down 1 to the right 1, I'm going to go down 2 to the right 2, just so I don't have to do as many dots. But negative 2 over 2 is the same thing as negative 1 over 1. Yeah. So, down 2, or you can do down 3 if you want to the right 3. Just make sure however many you go down, you go to the right that same number.
Did you say down 2?
Yeah, I did down 2 to the right 2 here, and I went down 3 to the right 3. As long as it's the same number, then you're okay there.
Why are you doing it?
Mostly to confuse y'all. Right. Well, y'all look.
Let's start.
Here, real quick. Tell me what negative 1 divided by 1 is. Negative 1. Alright, what's negative 3 divided by 3? Negative 1. And so in other words, as long as I go down the same number of units I go to the right, I'm just doing that so I don't have to put so many dots. Because I only need 2 to make a straight line with the ruler especially. Okay? And so I can go up and to the left that same way. Okay? So that's going to be a dashed line because it says less than, it does not say equal to. So again, which way am I going to shade? The direction got changed on this one. So the line slanted differently, but it's still less than, so it's actually going to go the other direction.
Extra.
So yours should be something like this. All right. Question. All right. Let me let y'all try to do one here. Six. Alright, so I want everybody looking at this file, working on it.